Hey guys, this is your second video on solving compound inequalities. The learning targets for this lesson are I can solve compound inequalities involving the word or, and I can use interval notation to represent compound inequalities. We looked at compound inequalities with the word and in the previous video, and we took a little look at interval notation, but we're going to focus really heavily on it in today's lesson. So let's get started. So the word and means the overlap or the intersection of the two inequality solutions, and we've already kind of looked at that together in the previous video. The word or means the union of the two, and we're going to treat those completely differently than the word and compound inequality. So it's really important that you understand that and or make a great deal of difference in your answer. So looking at this first example, what I want you to do is start just by solving each one of these individually. Then we'll talk about the fact that this is an or compound inequality and how that affects the overall solution. So pause the video now and go ahead and solve both of these inequalities on your own. Push pause. So at this point we see we're going to end up having to divide by a -2. And I wanted to mention here that anytime we divide by a negative number, or if we multiply by a negative number, we have to flip the inequality symbol. So we get y is greater than +3 for the first solution. Pause again and go ahead and solve the other one if you haven't already. So in the second one, we only had to divide by the number +4, so the inequality symbol remains as less than or equal to -2. And these are joined by the word or. So we're going to have to take a look at our overall solution set. Let's make some number lines. So here are 3 number lines. I'll do each of these solutions on one of the number lines, and then on the third number line we'll do the overall solution. So in red, let's graph the first one. Y is greater than 3. We're going to get an open point at 3, and we're going to shade everything that's greater than 3, including the arrow. In the second one, y is less than or equal to -2. We'll get a closed point at -2 because it does say it could equal it, and shade to the left, including the arrow. So these are the two graphed solutions individually, but we need to look at the overall solution. Well, we know that the word or means union. So the union of these means that anything that was graphed on the first or the second number line goes into our overall solution. So it's just like we take anything that was graphed on either one and transfer it all to the final number line. So this number line shows the graphical solution for this compound inequality. If we write it in set builder notation, I'll write that at the top. We would say y such that y is greater than 3 or y is less than or equal to -2. So it's pretty simple to put in set builder notation. The interval gets a little tricky here. For interval notation, we would read our number line from left to right, and we would say that this arrow here represents -infinity. And then our solution goes all the way up to -2 and we stop. Then we jump to 3 and we go all the way up to +infinity. So as intervals, here's what the solution looks like. -infinity, it's a little sideways 8, up to -2. -2 is included, so we use a square bracket. And then we're going to use this symbol, capital U, stands for union. Union with, curvy bracket, start with 3 because 3 is not included, and we go all the way up to +infinity. So that is the interval solution, and we'll take a closer look at interval notation as we go along. Okay, here's our second example. Let's go ahead, pause the video, go ahead and solve both of these on your own, and then we'll take a look at the graph. Okay, so when we solve these, we just have to divide each one of them. We get x is greater than or equal to 1, or x is less than 6. So on the first number line, we'll graph x is greater than or equal to 1. closed point, everything to the right because it's greater than, including the arrow. For the second one, x is less than 6, open point, shade everything to the left, including the arrow. And for the overall solution, everything that is greater than or equal to 1 or everything that's less than 6, we're looking for the union of these. Everything that was graphed on either one gets transferred to this final graph. What we end up with is the entire number line gets shaded. So I'm not just looking for an overlap here. If I had said the word and, I would be looking for the overlap. Overlap would be from 1 up to 6, right? If we were looking for overlap, that would be our region. We were looking for the union, anything that was graphed here or anything that was graphed here, and that happens to be the whole line. So we could say that the solution here is all real numbers. Or we could use this double bar R. That's the symbol that means all real numbers. In interval notation, we would say all numbers from negative infinity up to infinity are included in this solution. So I said we'd take a closer look at interval notation. Here it is. We're going to just take some intervals and put them on some graphs and write them as inequalities as well. So let's look at the first one. What is the graph of -4 to 6 with a closed interval at -4 and an open interval at 6, or a closed boundary, I'm sorry, at -4 and an open boundary at 6. So let's say -4 is here, +6 is here. We would have a closed point here, an open point at 6, and we would shade everything in the middle. This is one of the between problems. This answer, by the way, would have to come from an and compound inequality because it's talking about an interval in between two numbers. How would we write that as an inequality? Well, we would say x falls in between -4 and 6, where -4 was included. So we get the or equal to there. So there it is as an inequality. The next example, what is the graph of -2 to 7, where -2 as a boundary is not included and 7 as a boundary is included? Of course, if I were writing a test, I would put all of the numbers in between -2 and 7. But it looks like this. And that, of course, has to come from an and compound inequality, where we've got our solution being expressed by all the numbers between -2 and 7, including the 7, but not including the -2. This one just asks me to write a graph for an or compound inequality. And when we're doing ors, we really don't have to do 3 number lines. We could just go to 1 number line and graph it all on this 1 number line. So I'm going to do some labeling. -1, 0, 1, 2, and 3. How about I'll go to -2. All right, so x is all the numbers that are less than or equal to -1. Less than or equal to -1 would include -1 and shade everything to the left. Or x is greater than 2, so that's going to include all the numbers that are greater than 2, but not include the 2. So there's the graph of this compound inequality. Again, we're not looking for an overlap with or. We're just taking all of these inequalities and putting them onto 1 number line. So then when we're asked to write that as an interval, we would start with the left of our graph and go to the right. So starting at the left, we're starting with -infinity and going up to -1. So that interval will be -infinity up to -1 and put a bracket. Then we're going to union that with this second interval, which is going to start with 2 and go up to +infinity. And that second interval will be an open bracket at 2, and we're going up to +infinity. So there is my solution in interval notation. The last one is just saying, do you know how to do this when it's not compound? This is supposed to be simpler. So what's the graph of y is greater than 7? So let's say 5, 6, 7, and 8. Y is greater than 7, would not include the 7, and would go up to infinity. And what is that in interval notation? Well, we would start with 7, and we would go up to positive infinity, but 7 is not included. And let me say this one more thing about our intervals. When we're talking about infinity, you probably have noticed, but we're always getting a curvy bracket beside an infinity symbol. Okay, so infinities always get a curvy bracket beside of it in interval notation. So hopefully you can say that I can solve and graph a compound inequality involving the word or now. Remember, that involves unions. And I can understand interval notation to express my answers. So hopefully you've accomplished those things through this video, and I will see you in class. Thanks.